In today's video, you will use all 6 squares of your notes. So be ready to write and listen because I'm going to say a lot that might not necessarily be on the screens. So let's start off talking about something that's pretty familiar with us, to us, which is wind formation, or just wind, right? We observe wind pretty much every day. You can see the trees rustling. You might see leaves floating in the air. That's all wind. But how does that form? Well, we've talked about pressure. We've talked about what it is. We've talked about high versus low pressure. Well, now we're going to actually apply that. So when that cool air sinks from the atmosphere and it's getting pushed down, making that air more dense, we're going to say that that is going to be a high pressure system. If it's pushing all of that air down, that's going to create more pressure, correct? Yes. So then let's look over here. In a low pressure zone, it's when that warm air is rising up and there's less, it's less dense, so there's less pressure pushing down. So we're going to have a low pressure zone. And what did we say? How was these systems move? They moved always from high pressure to low pressure. So how that air moves is through wind. It's going to always move from high pressure to low pressure. Wind is going to push that air from high to low. So we see this on a bigger scale than just what we see daily out the window. We see this along the globe. We see this in global winds. You may or may not have heard about this before. But global winds are caused by the uneven heating between the equator and the North and South Pole. So let's look at our little example here. Here's the Earth, but we can see that the sun's rays, hit that equator dead on, but they're not necessarily hitting the poles as much. So this kind of creates, uneven heating it does create uneven heating among the globe, which causes pressure systems to be different. So for example, at the poles, the sun reaches there less, all right? So it can't heat up as much. And this air above it becomes cooler and dense, and that creates a high pressure among the poles, all right? Because it's cooler, it's dense, it's not getting as much heat. But then we look over here, and we see that concentrated light that's hitting the equator, well, that air is going to warm, and it rises. And so what did we say? When that warm air rises, down here is low pressure. So at the equator, heat rises, that air rises, we get low pressure. At poles, that air is going to cool and become dense, and that's going to create high pressure. But what really, after those winds have been created, now we have to think about how they're spinning throughout the world. So let's look at this diagram first. If you see where these little dotted arrows are, those global winds should theoretically flow from the low or high pressure to low pressure, right? So they should be flowing straight to the equator. However, because our Earth spins on an axis, we have to deal with the Coriolis effect. Coriolis effect. In the northern hemisphere, winds are going to curve to the right in the direction of motion. All right, so if the Earth's spinning this way, they're going to curve to the right. However, in the southern hemisphere, they curve to the left. So you see, instead of going straight, because the Earth is spinning, they curve. All right, and that's the Coriolis effect. We see this not only in wind, we see this in oceans and all of that as well. So these global winds, they kind of create bands across the globe, just because there's kind of these patterns that are the pressures because of the heat that's being created. So the bands of calm air separate wind belts. So we have a couple calm air bands that are going to separate these 3 wind belts. First, we have the doldrums. This is where low pressure is created near the equator, and moist air is produced here. So the warm air rises to the top of that troposphere, which is obviously the atmosphere's lowest layer, right? That's where all the weather happens, and it spreads out towards the poles. And then that rising moist air produces that heavy rain, and during the hottest months, heavy evaporation from the ocean in the water produces a lot of tropical storms. So we said, right there at the equator, it's getting a lot of heat. So that cold, dense air is rising, and it creates, as it rises and cools, it creates those clouds, producing a lot of heavy rain and tropical storms. Then this is my favorite because it's a funny name. We have the horse latitudes. This is where it's high pressure zones, and they're located at about 30 degrees north and 30 degrees south of the equator. So going back to our latitude and longitude, 30 degrees north and about 30 degrees south of the equator. These high pressure zones tend to be very clear and dry, because that warm air is traveling away from the equator and it sinks in these regions. And so because it's sinking, that warm air is sinking, we tend to have clear and dry in the horse latitudes. The wind belts. Now, I'm going to give you a little brief overview, and we're going to do a lot with this in class, kind of showing you where on the globe and how they move. But for now, you really need to be able to identify which direction the wind is blowing in both of these, or all three of these belts. With trade winds, they blow east, and they dry out near the equator. So they're blowing east and dying out, they're dying out near the equator. Next, we have the westerlies. The westerlies, well, just as their name states, blow west, and they blow towards the poles, so the top of our and bottom of our globe, and this is what brings storms across the USA. All right, and we're going to look at that as well. And last but not least, we have the easterlies. Where do you think they might flow? Blowing from the east. And polar regions, they flow from the polar regions to about mid-latitude. All right, and we're going to look at that on a globe as well. And some of you have been asking about this in class. Well, we have got jet streams. So what are jet streams? Well, jet streams flow in the upper troposphere. All right, they flow from west to east. And each hemisphere has a polar and a subtropical jet stream usually. So normally there's about 4 that are going on around the globe. Now, jet streams have a lot to do with weather and air travel, all right, because that jet stream is flowing across, and it pulls that cool air down from Canada into the USA. So that's what's going to cause some weather changes, and it pulls warm air up into Canada. So it's kind of cycling that air through loops. And so when it dips down, when that jet stream will dip down, the scientists need to know that and when it's going to do that so that they can accurately predict what our weather is going to be like. We also have it affecting air travel. So when planes, if it's going to be up there in that upper troposphere, that's where our planes and stuff are traveling, right? So it needs to be able, or they're going to affect what those planes are able to do, if they're able to stay up there, if not. And time, depending on which way you're flying through it, your travel times can be lengthened or they can be shortened. So you're going to hope you get a little nice ride on that stream. All right. Last but not least, we've talked about those winds that are traveling thousands of kilometers around the globe. But we also have winds that affect us here daily, and we're going to call those our local winds. The 2 specific that we're really going to talk about are sea breezes versus land breezes. So in sea breezes, oh, my little thing got messed up here. In sea breezes, What happens to land and water when it's being heated? Well, land is going to be heated a lot quicker. So during the day, of course, so during the day, that land is heated quicker, so that warm air is going to rise up, remember, because warm air rises. So that warm air is rising, and it falls over here to low pressure, right? Because always from high to low. And that cooler air now is going to blow in from the water, so that it's going to circulate. Hot air going up, cooler air coming down, hot air going up. Do you see how that works? But during the night, we have land breezes, which come from that land cooling off a lot quicker than the water. So that cool air from the land flows over the water. At night, that warm air from the ocean comes up back to the land, and so on. It makes that, cycle of breezes. This will affect you if you are at the coast, right? Because if you're on the coastline, you've got land, you've got water, and that circulation is going to happen. So during the day, warm air rises out to the ocean, brings it in. That was during the day. During the night, that heat from the water comes up and flows over the land, up over the land. Make sense? Hopefully so. We're going to do a lot about placing these on a globe, so don't worry if you're kind of confused on which is flowing where and whatnot. So keep calm and rock on, Heilbronn Hawks.